Hello friends, hope you're doing well. Welcome to the 21st episode of the SAT ACT series. In this session, we are going to specifically focus on inequalities. I've been getting a lot of requests from you all, and overall also I'm seeing a lot of confusion going on this topic. So let's dedicate some time and understand how to solve these inequalities, right? Now, solving an inequality is very similar to solving an equation, right? However, there are just a few nuances which we have to take care. So let's get into that right now and see what those things are. So let's say that we have an inequality something like 2x minus 10 plus 4x is less than minus 200, right? As we would do in an equation, we will combine the like terms. So 2x plus 4x is 6x minus 10 is less than minus 200, right? We'll bring this minus 10 to the other side. So we'll do plus 10 here, we'll do plus 10 here. We get 6x is less than minus 190. And then we divide by 6 on both sides, right? And we get x is less than minus 190 over 6, right? Whatever that is. So basically, the solution set of this inequality is nothing but all values of x which are less than minus 190 over 6, correct? So as simple as anything can be, the same thing what we would do in solving an equation is what we are doing here. The only catch here in this linear inequality is that instead of minus 4x, suppose we had minus 2x, minus 4x, right? So instead of the plus 4x, if we had minus 4x, how would it look like? Again, the same thing. We'll combine the like terms. We'll do minus 2x minus 10 is less than minus 200. Right? Move 10 to the other side. So minus 2x is less than minus 190. And now here we would have to divide by minus 2 on both sides. Right? The moment we divide any inequality by a negative number, the sign of the inequality flips. That's the only catch we need to be aware of. So in this case, once we divide by minus 2, on the left side we get x, and this flips, this inequality sign flips, and from less than it becomes greater than, equal to, minus and minus cancel here, so 190 over 2 or 95. So x is greater than 95. So again, just to summarize, right, in case of a linear inequality, all we do is the same thing as we would have done in an equation, but in the end, to find the value or the solution set of that variable, if we have to divide by a negative number, then this sign flips. The sign of the inequality flips. As simple as that. Okay, let's move to another type of inequality, which is absolute value inequality. Correct? Something like 2x plus 5 absolute value is less than 20. Right? What do we do here? We make two scenarios here, and in one scenario we take the positive value of this number, and in the other scenario we take negative value of this number. What I mean by that is that when we expand this, or when we remove this absolute value, we write it as 2x plus 5 is less than 20. Positive value of this number, keeping the same sign. When we take the negative value of this number, we will flip the sign. So 2x plus 5 is greater than minus 20. Correct? So these are the two scenarios which we get in case of an absolute value inequality, and then we solve them like the way we would. So 2x is less than 15, or x is less than 15 over 2. So that is one set of solution. From here we get 2x is greater than minus 25, or x is greater than minus 25 over 2. So essentially, all values of x which are greater than minus 25 over 2 but less than 15 over 2 form the solution set of this inequality, right? Again, just to reiterate, in case of an absolute value inequality, we make two scenarios. In the first scenario, we take the positive value, or whatever value it is there, and we keep the same sign. And in the other scenario, we flip the sign of this number, and we also flip the inequality sign, and we solve for it. Let's take another quick example of the absolute value inequality. So let's say we have something like minus 2x plus 8 absolute value plus 10 is less than or equal to 50, correct? The first thing we got to do is to move this 10 to this right side, right? The rule which we set of making two scenarios, before that we have to move everything else to the right side. There should only be this absolute value inequality term on the left side, okay? So the first thing is we move this 10 here, so it becomes 40. Do minus 10 here and minus 10 here, right? That's the first thing. Now we make the two scenarios which we talked about in the previous example, right? The first scenario would be minus 2x plus 8 is less than or equal to 40. So same values, same number, same sign. And in the other scenario, we will put a negative sign. We will change the sign of this number, and we will also change the sign of the inequality. So it will become minus 2x plus 8 is greater than equal to minus 40. Same sign of the number, same sign of the inequality, opposite sign of this number here, opposite sign of the inequality, and then we solve them. So minus 2x is less than or equal to 32, and then we divide by minus 2 here, we divide by minus 2 here. As we saw, whenever we are dividing by a negative number, the sign changes. So it gives us x is greater than or equal to minus 16. So that is one solution set we are getting from this scenario. Let's see what's happening here. Minus 2x is greater than or equal to minus 48, because we're doing minus 8 here and minus 8 here. Then we are dividing by minus 2 here and minus 2 here. When we divide by minus 2, as we saw, the sign of this inequality will flip again. So x is less than or equal to 24. Minus minus cancels, 48 divided by 2, we get 24. So this is the solution set we get from this scenario. So basically all values of x which are greater than or equal to minus 16 but less than 24 will be the solution set for this inequality. Just to again reiterate, we moved 10 to the right side, we got this, and then we wrote the two scenarios. In the first scenario, same sign, same sign. Same sign of the number, same sign of the inequality. In this scenario, opposite sign of this number and opposite sign of the inequality, and then we solve them separately to get the solution sets. Let's talk about the third type of inequality, which could be a quadratic inequality, right? So we talked about the linear inequality, right? We talked about the absolute value inequality, and the third category could be quadratic inequality. So let's say that we have something as simple as this. 2x squared is less than or equal to 72, right? Obviously, the first step would be to divide by 2 on both sides. And when we divide by 2 on both sides, we get this, right? X squared is less than or equal to 36. Now, we will take the square root on both sides because all we want to do is to find the solution set for x, right? So we kind of taking the square root on both sides. Now, as we know, the square root of a number is both plus and minus, right? So square root of, let's say, 25 is plus and minus 5, right? Square root of 16 is plus and minus 4, correct? So when we're taking the square root on both sides, the square root of 36 will give us plus 6 and minus 6. But what we got to do is that when we take the positive value of this square root, we keep the same sign of the inequality, and when we take the negative value of the square root, then we flip the sign. So what it means is that it will be x is less than or equal to 6 and x is greater than or equal to negative 6. So this is the solution set for this inequality. Again, positive square root value, same sign. Negative square root value, flip the sign. So all values of x which are greater than minus 6 but less than equal to 6 will be the solution set for the original inequality. Let's take one more example of a quadratic inequality, right? Unlike the previous example, we have a full-fledged quadratic function in the form of ax squared plus bx plus c, which is greater than or equal to something, in this case greater than or equal to 0, right? So what we do in this case, we first find the x-intercepts or the roots of this function. We want to know what are the x-intercepts or what are the solutions or roots of this quadratic function. In this case, we can factor it, and it will be as simple as x minus 3 times x minus 2 is greater than or equal to 0, correct? Now, what are the two roots of this function? 3 and 2. X equal to 3 and x equal to 2. What it means is that if you were to visualize this function on a xy axis, right, it would be something like this. This is 2 and this is 3, let's say. Right, so these are the two x-intercepts, 2 and 3. And we know that this parabolic function will be opening upward because the value of a is 1, which is positive, right? When the value of a is positive, it opens upward, and when the value of a is negative, the parabola or the quadratic function opens downwards. So in this case, this function will be opening upwards. So the function will be something like this, correct? So the function is going to be opening upward, and the x-intercepts or the solutions are going to be 2 and 3, right? Now we got to see for what values of x this function is greater than or equal to 0, because that's what they're asking. When we look at this, all values of x which are 3 or greater than 3, right, the value of the function will be greater than 0. Similarly, all values of x which are less than or equal to 2, the value of the function is 0. The value of the function is less than 0 only in this portion between 2 and 3. So the answer for this inequality would be all values of x which are greater than or equal to 3 and all values of x which are less than or equal to 2. Right? So everything to the right side of 3 and everything to the left side of 2 will be the solution set for this inequality. Let's take one last example of a quadratic inequality. So let's say we have something like this. Minus x square plus 120x minus 2000 is greater than 0. And we have to find the solution set for this inequality. Again, as we discussed earlier, the first thing is to find the roots of the inequality of this function, quadratic function. We can use the quadratic formula for that, or we can just factor it out depending upon what is easy. In this case, we can clearly see that the two factors will be 100 and 20, because 100 plus 20 will be 120 and 100 times 20 would be 2000, right? Take care of the fact that these two are negative, so the product of those two factors has to be plus 2000, right? So essentially we get something like this. Right? And let's say we take minus x common, so x minus 100, and here we take plus 20 common, so x minus 100. So x minus 100 and minus x plus 20, right? So these are the two factors of this quadratic function. So what are the two x-intercepts? The two x-intercepts would be x equal to 100 and x equal to 20, correct? So these are the two x-intercepts or the roots of this quadratic function, right? Let's try to visualize it quickly and see how it will look like. So 20 and 100, let's say 20 is here and 100 is here, correct? Now this original inequality has a negative a, right? A is minus 1 here. It means that this parabolic function will be opening downward, right? So it will be opening somewhere like this, correct? Now what are they asking? They are asking for the solution set when this will be greater than 0. Clearly it's greater than 0 in this portion, right? In this portion, the function is greater than 0. Before 20 it's negative and after 100 also it's negative, correct? So basically the solution set for this inequality would be x is less than 100 but greater than 20. Again, what we do is that whenever we have a quadratic inequality, we try to find the roots by factoring or by the quadratic formula. Once we find the roots, right, we get a sense of whether this quadratic function will open upward or downward, and depending upon that we can find our solution set. Hey guys, hope you liked the video and it gave you some sense of how do we take care of the inequalities, whether they are basic linear inequalities or absolute value inequalities or quadratic inequalities, right? Keep practicing. In case of any questions or queries, please feel free to reach out to us at info.mathletes@gmail.com. See you in the next session.